A very good morning to one and all present here. It gives me immense pleasure to extend to you a very warm welcome on behalf of MSSRF. No challenge poses a greater threat to future generations than climate change and high global population. Professor Alok Bhargava, an eminent econometrician from University of Maryland, is present here to make a presentation on climate change, demographic pressures, and global sustainability, followed by a discussion chaired by Professor M.S. Swaminathan, founder of MSSRF. Now I request Dr. Anil Kumar, the Executive Director of MSSRF, to deliver the welcome address.
Respected Professor, today's speaker, Professor Alok Bhargava, ladies and gentlemen, and my dear colleagues. Professor Alok Bhargava is a very distinguished and accomplished professor in the area of econometrics. When I had gone through your biodata, so very rare to have both mathematics and economics, that combination together. He did his mathematics degree, base degrees in mathematics. Later on, he moved to the economics. And he has this economics degree in both the typical economics, the major economic stream, as well as the econometrics. He did his PhD from London School of Economics. And he moved from different disciplines. In fact, if you look at even his affiliation, currently he is the professor of the public policy, School of Public Policy in University of Maryland. But he was a teacher and a visiting professor of Harvard University, University of Houston, and many reputed international universities. And also he was an advisor for the World Bank and also an advisor for the OPEC countries. So we are really privileged to have you here. He will be talking about the climate change, demographic pressures, and the global sustainability. Looking into three major variables. One is the agricultural decisions. I'm sure you will be focusing on particularly the land use decision and the migration. So how the migration affect the kind of global sustainability. So we are very happy to have sir you here, and we look forward to listen to your talk. Thank you.
Thank you very much for inviting me, and it's my great privilege to be here and present this article. I had presented a previous article last year, and Dr. Swaminathan invited me again, so I was very happy to be back within a year. And this paper is talking about general issues related to climate change. And one of the problems is that in many disciplines, people are focused on what is of interest to them. So physical scientists in particular, they have a different viewpoint of climate change. And I'm going to describe all kinds of problems that actually arise and how we could formulate effective policies that are evidence-based and not just based on some prior hypotheses or beliefs or biases and so on. So let me just try to talk for about 45 minutes and try to present this paper. Now, we all know that increases in temperature and sea levels are likely to reduce habitats, and they are likely to reduce agricultural productivity. And there are also recent groundwater shortages, especially in South Asia and some sub-Saharan African countries. And the fact is that population growth and higher life expectancy and living standards do put greater pressure on environmental resources, and especially in greater consumption of animal foods really requires higher levels of water to produce these foods. And it leads to rapid depletion of some of the natural resources. Now, the United Nations, of course, is very interested in these issues. And for example, they've come up after the Millennium Development Goals with these 17 Sustainable Development Goals. But the problem in these Sustainable Development Goals is, they are not likely to be met anytime in the time frame that the United Nations has in mind, because they haven't quite recognized, firstly, the interdependence between the various goals and also the role of population. In fact, if the United Nations were to spell out exactly how they're going to achieve these goals, they would have to deal with issues such as, what is the level of population that can be sustained given the natural resources. So just as an example, if we consider the sub-goals of ending hunger and food insecurity, improving education quality, providing adequate sanitation, all these are adversely affected by population growth. When population increases beyond a certain level, it becomes very difficult, especially for poor households, to educate their children, and especially those who are born at high birth order. So an example is in the abolition of school fees in Kenya in 2003, and it doubled almost the school enrollment. Now most children in sub-Saharan African countries, 50% children drop out after primary education. And so initially it was a great enthusiasm that so many parents were enrolling their children, but given the limited resources that the schools had, many of the parents who could afford it moved their children to private schools. But in the end, not much came out of it, because many of these households have 5, 6, 7 children, and some of the parents are actually HIV positive, and it was really not possible to raise the educational standards in Kenya despite the abolition of tuition fees. Now, in general, we know from studies like the demographic surveys that children who are born at high birth orders, 4th child, 5th child, so on, in countries like India, they have lower heights, lower weights, and lower vaccination rates. And so clearly, in rural areas where there are poor households with large number of children, it is likely that they cannot take care of them as well. And in fact, I'm going to present some results or some findings or reported findings from the National Family Health Survey 3 and 4, showing you, what proportion of these children are actually not really wanted by their parents. But anyway, by contrast, if you look at countries like Japan, South Korea, and China, they reduced family size, especially after the Second World War, educated the children, and created these large skilled labor forces. And in fact, with globalization, it was possible to increase productivity or value added of the labor force, and that is how they developed. By contrast, if we look at countries in sub-Saharan Africa, where total fertility rates are still very high and a large proportion of children are not really educated, they are not likely to grow in the long term, at least in economic terms, as a result. So the formulation of evidence-based policies really is critical now in the wake of climate change, which is putting additional pressures on economic activity, human activity, and so on, to which I'll just come. Now, it's certainly true that greater renewable energy can reduce carbon emissions, and I'm going to talk about them very briefly here, but I know it's a topic of interest to Dr. Swaminathan, but the fact is that the role of emissions of methane and nitrous oxide, especially from agriculture, has not been well studied empirically, despite these FAO stat database. And in fact, I'm looking at these data these days, and there are over 20 gigabytes of data, but scientists are more interested in projections using simple models to say, well, what might happen, but actually we do have some level of information on many countries. What is more is that in many of these projections made by scientists, they don't account for positive and non-linear feedback loops due to rising temperatures. So for example, higher amounts of carbon are metabolized, and with increases in temperatures, and its carbon sequestration is also adversely affected. And so we are now in a state where things are actually much worse than many of these scientists project using very simple empirical models. Now, of course, groundwater depletion is a serious problem, and I will be focusing on that in a few minutes. especially in the Indian context, because we have data on wells as well as we have data from these GRACE satellites, to which I'll come. Now, there's a belief in many circles, international bureaucracies, United Nations, and so on, that if we had sufficient funds, we can really combat climate change. Now, that may be possible, but the fact is that we have a lot of obsolete machinery in developing countries, which is very high polluting, and it would require massive transfer of resources to actually replace these antiquated machinery. Now, you know, it is true that most people agree that there should be a carbon tax of some kind, but we saw recently in France, when they tried to impose a carbon tax, the citizens revolted, and the so-called, you know, these yellow vests or gilets jaunes, and you know, they refused to pay higher taxes, indirect taxes involving carbon. So I think that, you know, even though scientists and policymakers all understand that we need to tax carbon in general, because of globalization to some extent and increases in income inequality in developed countries, you know, people have limited resources. So if you try to tax them further, you know, they already feel they're being taxed very high, and you know, they can revolt. So I think developing countries need to be careful in terms of not expecting massive infusion of resources, even though people like Al Gore and others think that, you know, renewable energy could take care of 90% of the world's energy needs. But the fact is that even to subsidize some aspects of climate change prevention in developing countries is going to be a challenge. I mean, many of these countries make promises, but then they are often not able to live up to those commitments. So there are three problems. Well, I'll just come to it in a minute, but you know, it is certainly true that public policies need to address issues of fertility, or you know, population growth, agricultural productivity, which is of course very important, and migration from poor countries is also an essential component. So for example, many scientists think that, you know, is somebody a climate migrant? Now, if you look at countries like Bangladesh, where some houses, or many people are living in houses with 3 inches of water, they're thinking of building floating houses, and many people migrate to Indian states such as Assam and so on, and you know, we often hear about discrimination, violence, and amongst the local population who don't really want these migrants. Now, you know, many of these scientists are saying, well, is somebody a climate migrant, or is he an economic migrant? But the fact is that if poor people are living in Bangladesh, for example, and they cannot support their families, and they have all this water on the ground, you know, it doesn't really matter whether they are climate migrants or they are economic migrants. They're all poor people, so they need to be helped in some ways. So clearly, part of the problem here is that if you look at scientists like, say, Hardin, you know, he made this sort of strange claim that breeding of mankind cannot be achieved with an appeal to conscience. And this is an article which has been cited 40,000 times, and it makes no sense. So, you know, the fact is that it's all contradicted by voluntary decline in fertility in poor countries. Even in countries like India, if you look at states of Kerala, you know, the fertility rate is below replacement. So it is approaching, or it already has approached in Tamil Nadu as well. And a lot depends on child survival, as well as the provision of high quality health care and family planning services. Now, part of the problem is that demographers don't actually make a very good case for the importance of fertility. And in fact, they tend to sometimes think that fertility and child mortality are chicken and egg problems, which they are not. So, you know, the fact is that historically, child mortality goes down and then the fertility declines. But the point is that at any given point in time, it's these poor households in rural areas with limited access to healthcare and family planning services. They tend to have a lot more children, and you know, they experience much greater child mortality, especially at high birth orders. So it's not a simple or a difficult kind of a chicken and egg problem. In fact, it can be actually quite sorted out easily. And there's also this wave against Malthus's original thesis about population growing at geometric rate and food supplies possibly at linear rate. But Malthus was writing in 1798, and we do need very different frameworks for population growth and agricultural productivity and so on. So agricultural productivity can go up in the medium and even the long term, but the fact is that if population is increasing, especially due to access to healthcare and so on, there will come a point where it would be difficult to at least provide nutritious foods and so on, as to which I'll come in a minute, to a large number of people. So there are three sort of components to this paper. First, we want to reduce the unwanted fertility in developing countries, especially in rural areas. And we've seen that, I'm going to show you some figures for India, especially the northern states, where almost a third of the children were regarded as unwanted by their mothers. Now, the other point is, well, how can we enhance agricultural productivity? Now, true, if we have data on groundwater levels, as we have for India, that's useful, but now we also have these satellites, orbiting satellites, and they're taking these images and making some measurements, and these data are publicly available, but can we actually utilize them for formulation of evidence-based policies or not? So that's the issue that I'm going to be spelling out in detail here. And then, of course, migration is very important, and clearly if you look at the patterns of migration, international migration, especially the highly educated from developing countries, they end up living in OECD countries, and we need to somehow come up with policies which are beneficial for the sending countries as well as for the host countries. So these are the three themes that I addressed in this paper. Now, to come back to this unwanted fertility, in demographic surveys, each woman is asked about every child that she's had, whether the birth was wanted then or was wanted later or never. So unwanted fertility has been defined by demographers as, based on the missed time and unwanted births, and that we can compute from National Family Health Survey 3 and 4. I'll just show you in a minute. Now, there are also other issues of gender. So, for example, in these demographic surveys, they ask, what is the ideal number of boys the couple would like to have? What is the ideal number of girls? And so we can actually construct gender-specific unwanted fertility as well. And in fact, some of the problems in northern states, in India, in countries like South Korea, in China, is that they want certain number of boys and certain number of girls, and that can lead to high male to female ratios. So for example, even in China, there are about 117 boys for every 100 girls, and we've seen these problems in India as well when there is a preference for male children. So let me just show you some of these unwanted fertility in the state of Bihar, Rajasthan, Madhya Pradesh, and Uttar Pradesh. And these are from National Family Health Survey 3 and National Family Health Survey 4. So for example, in Bihar, the average woman has 4 children, and in National Family Health Survey 3, which was in 2005 to 6, 1.5 of those children on average are unwanted. Now, of course, these numbers are declining over time. So if you look at National Family Health Survey 4, they're still over 3.5, about 3.3 children per woman, and about 1 is still unwanted. A similar pattern in these populous northern states, in Rajasthan and in Madhya Pradesh and in UP. Clearly, fertility is declining, but still there remains almost 1/3 of these children are actually unwanted. So how are we supposed to educate them? How are we supposed to improve their nutritional status? And that's not so easy. So just to come back to the percentage of births, really, unwanted births in 2005 and 6 were 40% in Bihar, and then around 30% and 40% actually in UP. And really, they did show some decline thanks to the increase in family planning and healthcare service uptake. But overall, from a nutritional viewpoint, unwanted births are detrimental for maternal nutritional status. So for example, the calcium stores are being depleted. Women, especially, anemic women, do not have very high iron stores, and so repeated births in very short intervals are bad for maternal health. They're bad for children's nutritional status and education, because many of these women can't really, support these children. They're also working themselves, and so it becomes difficult. So this whole idea that India somehow has a population dividend is a bit, out of date. And we have a large number of children, especially in rural areas, who are poorly educated, and their productivity is not likely to be particularly high in the future. Now, I know the Prime Minister Modi was making these statements from time to time, how the large population in India is an asset, but one of his advisors I happen to know, and I tried to tell him not to make these statements because, we're, as I'll talk to you in a minute, we are depleting a lot of groundwater and so on, and population is more a liability than an asset. Now, so for example, between 1980 and 2010, there was a 77% increase in population in India. And in fact, the effects of population growth on well depths, which I'm going to talk more about in a minute, were non-linear. And it's not easy to simulate. Now, if you ask a scientist, well, what is the effect of population growth on water tables in India? They'll say, well, why don't we assume they decline by 1% every year? But India is a large country. In some states where you have a lot of rainfall, the groundwater depths are not declining that much or increasing that much, whereas if you look at the northern states, which receive less amount of rainfall and are also experiencing high population growth. So for example, these effects were non-linear, and these states, Bihar, Madhya Pradesh, Maharashtra, Rajasthan, Uttar Pradesh, and West Bengal, they experienced population growth of greater than 33 million people, which was the kind of a turning point in the models that I estimated and were published in environmental research letters. And these states, population growth was positively associated with well depth. So it's not good enough to say, oh, we can assume something about population growth, we can assume something about water depth. We really need to have evidence on these things and then see what sort of policies we should propose. So for example, water shortages are becoming increasingly common, even in states like Tamil Nadu that receive fair amount of rainfall. And this is going to continue in the future because of increased living standards and the consumption of animal products that in fact require much more water use. So, from an agricultural decision viewpoint, we agree that it's important to grow nutritious crops. And so, for example, the Harvest Plus program, with which I have worked previously, in fact, I wrote the paper with the famous nutritionist Nevin Scrimshaw and Howdy Boose, who became the director of Harvest Plus, and it became into a very big project of $250 million a year budget. They are developing these nutritious crops such as iron-dense rice and beans, iron-dense beans, and orange flesh sweet potato containing higher amount of beta-carotene, and they're implementing it in many countries, including the Philippines, India, Mozambique, and so on. And the point is that at a conceptual level, we can think about these problems, and when we have some good research and we can see what are the effects of, for example, of iron intake on hemoglobin concentration of women, then we can talk about specific policies. So that's how this whole Harvest Plus program came into being, and Howdy Boose also got the World Food Prize, and so did Nevin Scrimshaw. And the point is, we're trying to improve the nutritional status of large number of people in the world. But of course, from an agricultural production point of view, it's important to take into account, what are the crops that are being produced? So what are their transpiration efficiency, for example, and what is the level of groundwater use? So it's true, we can grow rice in Punjab, Rajasthan, and in Pakistan, for example, but we are depleting a lot of groundwater. And in fact, many of these state governments subsidize electricity, and I'll come to that a bit later. But the fact is that we want to improve the quality of diets, but at the same time, we want to make sure that these are sustainable strategies. So recently the Lancet Commission has published an article now, which is again very popular, will become popular, and which sort of unrealistically claims that the earth has the resources to support 10 billion people consuming nutritious diets. Now, if you look at the dietary patterns today, there are almost 2 to 3 billion people who are anemic, especially women in developing countries, because iron is a strange nutrient. It's the non-heme iron is found in many staple foods, rice, wheat, and so on, but it's not absorbed by the human body because the phytates chelate the iron in the intestine. And so, these people some of them are actually climate scientists, some are nutritionists, and some work for FAO, some for Harvard University, and so on. But I think it's a bit simplistic to think that we can actually support 10 billion people on nutritious diets. In fact, we can't even support 7.5 billion, that is the current population levels. Now, there are many reasons, I don't want to get into it, but yeah, of course, drip technology can reduce groundwater use, but the problem is that aquifers need to be recharged, so you need some sort of water runoff as well. So it's efficient to use drip technology in short and medium terms, and probably even in the long term, but the fact is that aquifers need to be charged. Now, it's kind of a historical irony that in the Indus Valley civilization in India over 5,000 years ago, they were very concerned about groundwater recharge. And so even the Mayan dynasty later on, they came up with taxation. If you were drawing a lot more water from the wells or open pits or wherever, you had to give a portion of that water in taxes. And so there was an incentive to reduce water consumption. By contrast, we seem to have forgotten our own history, and now we are depleting all these aquifers all over India, and we are running into severe water shortages. But anyway, we need to have some sort of an evidence-based approach. And so we can compare groundwater availability using these data from Central Groundwater Board, which I'll just describe in a minute, and also from GRACE satellites, which are orbiting they're two identical satellites, and I'll just come to that in a minute. So the Central Groundwater Board measures depths in over 30,000 wells. They're supposed to do it on a quarterly basis, but it's not so frequent sometimes for many wells and so on. So, but still, we managed to download all the data, and we have annual data from 2002 to 2016 on average groundwater depths. Of course, we also have the wells, but the averages here are computed for 495 districts in India, and these are the major districts. Now, we can look at these water depletion and see how it is progressing. Now, we can also look at terrestrial water storage anomalies. Now, when they say anomalies, they're just taking deviations from some time means, and these are about aquifer thicknesses, and these are assessed via GRACE satellites. The problem is that the resolution of these satellites is quite low. It's 200,000 square kilometers, and they're looking at differential gravitational pull or effects and using spherical harmonic functions with a very large degree of 60 for constructing these 1 degree by 1 degree grids, and there are 274 of them in India. Now, actually, the resolutions are really quite poor, and you can construct 3 degree by 3 degree grids for India, and there will be only 32 of them. So, you run into some sort of estimation problems as well. So it's a bit complicated problem, and those who work for NASA are promoting these GRACE satellites, and there are many people who are not happy with these GRACE satellites, and they're writing these papers, let's bring GRACE back to Earth. And, but we can actually do a comparison between water depths and assessed through wells, or measured in wells, and those assessed through GRACE satellites. So one of the simplest things of doing it is to look at the sample means, and these are the well depths in India, and you see that they are increasing, especially in the recent years. And we can also look at the coefficients of variations, which are really the variances divided by the mean. And these are quite steady and in a very compact sort of an interval. They don't show great fluctuation, but we can see that the well depths are increasing over time. Now, suppose we use the GRACE satellites. Well, we can see that GRACE satellites are much more erratic in the sense, there's a lot more variance. And even though aquifer thickness is actually going down, you can see that the standard deviations also show a lot of variation. And, this much higher, they fall into a much greater confidence interval. So in general, it is the case that these data from GRACE satellites are not as precise as the data on well depths. There's a group at IIT Kharagpur which has been arguing that actually the GRACE satellite data are as informative, if not more, than well depths, but that's really not true. In fact, they're interpolating to half degree by half degree grids. The data are really meant for something like 2 degree by 2 degree grids. And so I think there is a tendency among scientists to make all these assumptions and think that you could use some statistical methods to arrive at, to make these comparisons. But the fact is, these are very simple calculations. In fact, if you want to complicate these calculations, you can actually have an empirical model for average well depth or average aquifer thickness, and you can look at these time period dummy variables, and then this is a dynamic model. So the previous well depth appears as a regressor here, and this is a random effects model. So this is the between district differences, and this is a general error term. And you can estimate these models and control for these between district differences, and we can look at the patterns or the coefficients of these time dummies and see what is happening, and what kind of a persistence is there over time, what is the coefficient of the lag dependent variable for well depths as well as aquifer thicknesses. Now, I'm going to present some results in a minute, but one of the issues here is that how does fertility in developing countries and education affect migration levels? So we can look at the total migration to OECD countries from something like 45 sending countries. We are left with 39 actually. And we can look at it in years 2000, 2005, and 2010. So we can have a longitudinal data set, and we can see, well, what happens with what is the effect of average enrollment in secondary school? What is the effect of total fertility rate? What is the effect of GDP or the gross domestic product? And what is the effect of total population? And of course, again, this is a dynamic model. So what happens in 2000 affects what happens in 2005, and 2005 affects 2010, and so on. So we can estimate this model for total migration, also of the migration of the highly educated and the migration rates for the highly educated. Now, this is one of the problems in especially sub-Saharan African countries, with the HIV epidemic. There's been a lot of migration of physicians to developed countries, and it is actually worsening the quality of healthcare and so on. But I'm going to present these results because nobody's thought of this problem of previously anyway, of how does total fertility rate really affect migration. In fact, what happens in many of these developing countries where total fertility rates are high, like sub-Saharan African countries, children are poorly educated and the chances of migration are much lower than the highly educated. What is more is that when total fertility rates are high, it actually provides an incentive for highly educated people to emigrate, because they know that their children will face less, they'll get better education and face less competition. This was also the case for HIV prevalence in especially sub-Saharan African countries. So I'll just skip the technical details of the estimation methods here and present some simple results and try to keep the presentation on time. Now, so we have these well depths in India and terrestrial water storage anomalies for India as well. Now, the coefficients of the time indicators are more sort of jumping around in this from the GRACE satellites, whereas well depths, they're much more steady. But we see that, when you see come to time periods, 15, 14, these last few periods, the well depths are increasing in India, and even you can see from the GRACE satellites, the aquifer thicknesses are also declining. But of course, the data from GRACE satellites are much more approximate. If you look at what happened, how does the past affect the future, it's quite reasonable for well depths, but it's actually much higher for the data from GRACE satellites, partly because they're covering a large amount of area. They have no idea how many people are living near these areas and so on. Basically, what is happening is that if the water depths, if the water storage increases, the first satellite, the two satellites, Tom and Jerry, they call them. So the first satellite starts to accelerate a bit faster. So the distance between the two satellites is supposed to be 120 kilometers. It actually increases by a small amount. And by the time the second satellite has caught up, then the first satellite also has reduced its speed, and then the second satellite and the first satellite are at the constant distance. So it's a very approximate sort of formulation to figure out what the aquifer thicknesses are. And in fact, if you look at the within variances, really they're very low for well depths, but they're very high for these GRACE data. So clearly the GRACE data are actually more approximate than well depths in India, and these results are already discussed with you more or less for both well depths as well as terrestrial water storage anomalies. Now, for looking at migration pattern, you can see that yes, in countries where there's higher secondary school enrollment, at least for the rates of the migration by highly educated, these are positively associated using again 3-time observations. But if you look at total fertility rate, that's quite remarkable. So countries that have high total fertility rates actually have it depresses their total migration. It is negatively associated with the migration of the educated as well. But if you look at the rate, highly educated migrants, what their rate is, that's actually positively associated. So there's some level of brain drain from countries that have high total fertility rates. Now for GDP, again, if GDP is higher, then the migration rate for the highly educated would be lower. But now, of course, there are some nonlinear effects of GDP square and total population. But anyway, these results are more or less unaffected. But if you look at total population, higher the population, the greater are the migration levels, not only of the total and the highly educated, but also the rates of the highly educated. And so clearly, total fertility rate is not only important for reducing total fertility rate is not only important for educating children, improving women's nutritional status and so on, but also for the migration levels. We can see that countries with the higher total fertility rates, they tend to experience greater migration of rates of the highly educated people. So that's generally the idea here, and I'm going to just summarize some of the conclusions. But we really need to figure out ways of harmonizing international migration. So for example, you might think, well, countries like Sudan have a large area, they have low population density. I mean, why are these people leaving? Part of the problem is that the agricultural productivity is low, they cannot really sustain themselves on these farms and so on. And so those who can seek better opportunities migrate, take all kinds of risks, including of drowning, and try to migrate to OECD countries. So clearly, we can't think of climate change as just 1.5 degrees centigrade and, will that be met or not, because there are other problems there too. So as the ice starts to melt in Greenland, we can't really be sure how it is going to affect various currents globally. And in fact, some of the problems here are that scientists are using very simple models. And in fact, we need to be concerned with differential geometry. And, I mean, people like Gauss 300 years ago had been obsessed with this idea that Earth is curved, and so they developed all this differential geometry and so on. And the scientists are using very simple models which don't even have any kind of feedback effects. So I think that the problems are actually much more serious. Now it's true that Dr. Swaminathan felt that the Trump administration doesn't care about climate change. The problem is that the scientists have also underestimated the dangers, and I think overall we are heading towards a very difficult period. Now, I don't mean to suggest like Paul Ehrlich at Stanford, they've now come up with a new estimate that the Earth can sustain only 1 billion people. So where are we supposed to send these 6.5 billion who are here? And we have to worry about the constraints. We can't just make statements in vacuum. So again, these are the issues which I think have to be dealt with by social scientists, biomedical scientists, physical scientists. We've got to appreciate each other's discipline and see how far we can push what. So what are the broad conclusions from this study? Well, first of all, we really need actual longitudinal data for formulating evidence-based policies, for mitigation and adaptation policies for climate change. It's not just a simple matter of projections, because most of those projections are not going to, those simulations and projections are not going to capture important events, and nor are they capable of capturing the turning points, because simulations they just depend mainly on what you feed into the model. And if you don't recognize the interdependence, for example, greater metabolization of carbon with increased temperatures, and the interactions between various gases like methane, nitrous oxide, and carbon dioxide, they have to be taken into account. To some extent, we can do that using these complicated and elaborate data sets like the FAO stat, but there is hardly any effort. Most of the funding goes to making projections. And are these projections going to come true or not is really depends on various factors about which we make very, most of the scientists make very little effort. Now, in general, it's important to emphasize the benefit of small family sizes we've seen in Japan, South Korea, and really, that is fundamental for maintaining sustainable economic development. And it's a pity that the United Nations writes down all these complicated goals, 17 goals, and there are other 20 sub-goals, and they don't ever tell you how we could operationalize them. How are they going to be achieved? If they're not going to be achieved, and we know we are not going to we are going to miss the targets, then there isn't any point of setting such unrealistic targets. So, for example, the Gates Foundation came out with this conclusion that by 2035 there'll be no more developing countries left. Now, with climate change and reduction in agricultural productivity, it can happen that there'll be no developed countries left if we continue at this rate. So I think that, it's not a very good idea to make long-term projections with very limited information. Now, of course, we would like to use some of these technologies like remote sensing and try to figure out what are the water storage, terrestrial water storage anomalies. But the fact is that these GRACE satellites have very low resolutions. Now, it is true that NASA has sent SMAP satellites into the space, and they have a much greater resolution, something like 5 square kilometers. In some cases, they can look at the soil moisture, and those are important variables for improving agricultural productivity in developing countries. So, and for general agricultural decision making. Now, of course, we want to. Now, another issue which is not recognized widely is the role of agricultural subsidies in developed countries. And in fact, the agribusiness is lobbies and receives a lot of subsidies, especially in OECD countries, and makes food prices, especially of these processed foods and sugars and which are high in sugars and fat. They encourage overconsumption of food. People gain weight. And when you gain weight, your energy requirements go up as well. And so you need to consume more more energy-dense foods. And so this is one of the big problems. I mean, if the body size keeps increasing, 2/3 of the adult population, if not 70% in the US is obese or is overweight, and 1/3 is obese with a BMI of greater than 30. And they have higher energy requirements. So how are we supposed to have sustainable levels of agriculture with all this population growth, and people who are overweight would require and not only energy dense foods such as those animal products high in fat and so on. And I tried to make some of these points in a survey type article in the World Bank Research Observer in 2015. And I mean, agricultural technologies are of course critical, but we have to also look at the demand for food and try to make some sort of try to balance the supply and demand for agricultural product. Now, true, renewable energy generation should be subsidized instead of specially agricultural subsidies. And what is more, these agricultural subsidies make it difficult for farmers in developing countries to compete with farmers in developed countries. And OECD regularly dumps all kinds of foods, and these sometimes the subsidy received by each cow, for example, in some of the European countries is greater than the GDP of sub-Saharan African countries. So we have all these problems, and it's a bit simplistic to think that climate change is just a simple thing, and if we were to use more renewable energy, it will go away. No, we've actually got multidimensional problems here, and of course, international migration patterns are also important, and increasing the education levels will actually be good that is by reducing fertility also would be good for both the sending countries and the host countries. Now there are some people at the World Bank who really think that economic development can be greatly enhanced by the remittances sent by these migrants, and to some extent that may be true, but I think that the issue really is that if the migrants are better educated, they would have higher incomes, they'll be able to integrate better or more easily into these OECD countries. And so international migration is actually an important factor in climate change, even though, as I said, most of the climate change scientists are simply worried about who is a climate migrant and who's not a climate migrant, which I think doesn't really give us any information for formulating evidence-based policies. Now, it is true that the Earth may have already crossed a threshold of carbon dioxide and other greenhouse gases like methane and nitrous oxide, and migration and mitigation and adaptation policies are likely to have limited influence. And you know that we will see in the next few decades which way things go. But as I said, you know, and some people there have been papers in Nature, for example, by Heitman in 2008, who sort of regards all these simulations as quite useless because they're just not taking into account all these feedback loops. And I think these are important, and these are some of the issues I'm trying to look at with the FAO stat database. But again, it's a bit complicated in the sense that FAO doesn't collect data on its own, it just compiles what the countries supply, but still that's better than just saying what will happen if temperatures go up by 1.5 degrees or more, and you know we can make some projections, but you know how do we go about improving the sustainability of the planet? That requires a much more multidisciplinary approach. And you know, I've been working in nutrition for almost 30 years, and I've collaborated with people like Nevin Scrimshaw, who was one of the leading nutritionists of the 20th century. And you know, they appreciated the inputs of social scientists very much, but you know, that's not the case many times with other nutritionists who are much more sort of inclined to do some sort of a simple randomized controlled trial and say, well, this is the effect of changes in certain nutrients. And so I think the whole global food sustainability situation requires a very much broader approach. Now, overall, we shouldn't really be thinking that it's inevitable that the Earth will have 10 billion people, and our scientists have told us it's no problem, we can provide nutritious diets without worrying about the current situation. And so clearly, you know, we cannot go on increasing living standards and increasing population without degrading the environment. And as we are seeing already in countries like India, these aquifers are not being recharged, and we are having water shortages, especially in the summer months, and you know, these things are likely to get serious. So that's all really I wanted to say, and I'll be happy to answer any questions or if you have. Thank you.
Thank you, sir. I request the participants to keep the questions short and precise.
Sir, very famous Gandhian statement like nature had anything to satisfy everyone's need, but not anyone greed actually. And then like inequality is a political and policy choice in the sense attaining the basic things, you know, food, shelter, clothes, and then education, all depends upon the basic needs of humanitarian itself. Depends upon the political and policy choice, not reducing the total fertility rates. And then I don't think so actually. And then I agree with you that inequality, treating the inequality, worst form of inequality is treating the unequal as equal, I agree. But reducing that, Same, David Attenborough also came with a statement like you actually, reducing the fertility rates, but I think it's not. But thanks.
Thank you, sir, for your erudite lecture. You have covered well on the subject. So intricate functions like a transpiration of crops. I am sorry to say that you failed to mention about the greedy consumption of the people of developed countries in per capita energy consumption and product consumption. To tell you the fact, to quote of Mr. Bush as the President of America, I said that nobody is eligible to advise about the lifestyle of the United Nations citizens. When the world questioned about the extravagant energy consumption, and in the first period, that is swearing in ceremony of Mr. Obama also mentioned about this. The world is accusing us of this matter and we have to look into this. So when that, for example, the greenhouse gases, CO2 is the major part of the greenhouse gases and it is being produced by industries and transportation, by which the America plays a vital role. We consume nearly 23% the world when their population is only less than 5%. So you have to say about the demand driven energy usage. You have to reduce the demand of usage of products as well as consumption for comforts, and to what extent we have to do that has to be discussed. And I think the United Nations did not focus any light on that, and you also failed to do that.
Well, I mean, it's certainly true that consumption levels in OECD countries are very high. But if you look what's happened in China, for example, China now is the #2 or possibly even #1 economy. And, you know, there's a whole load of environmental degradation which has happened because of this rapid growth in China. Now, India and China, of course, want to see improvement in climate or environmental conditions and so on, but you know they rely a lot on coal. By contrast, if you look now in United Kingdom, true, these are the countries that started, benefited from the started the industrial revolution, benefited from it, and so on. And you know, at that point, everyone was focused on improving living standards. But is that not the case in countries like China and India today? If you look at the affluent in India, their consumptions, their lifestyles are approaching those of the citizens in the US. What is more, they're much less health conscious. So if you look at chronic diseases amongst educated, well-off Indians and Chinese, obesity, the rates are really approaching the same levels as many of the countries, including United States, United Kingdom, South Africa, and even now Mexico. So I mean, I think the point is true that developing countries should have much more margin. There was a time when Manmohan Singh was the Prime Minister and he made the statement that, you know, there's enough room for India and China to grow. And, you know, I mean, I think as an economist, if he knew a little bit more about environmental problems, he wouldn't make that statement because, you know, the fact is that we are very dependent on the monsoon patterns, on the flow of waters from these rivers in China into India. And, you know, there has to be a lot more emphasis on aquifer recharge. My point here is simply that, yeah, true, that if you really believe that naturally generated renewable energy can take care of a lot of, you know, things like electric cars and so on, you reduce carbon dioxide emissions. Now, for example, United Kingdom, they've stopped producing electricity from coal plants. And they've stopped mining coal more or less completely, except in a few quarries left for emergency purposes. Now you might say, well, you know, they caused the problem, they have to come up with a solution, but we in developing countries caused the problem, but we want to still have, you know, equal opportunity, if you like, in some sense, to grow. The fact is, we really can't be emitting any more of these gases. If you look at India, it has now 9 of the 10 most polluted cities in the world. So, you know, why, if it's true that you might invoke some Gandhian ideals and so on, And I'm sure there are lots of people in India who believe that, but overall for the country, our indicators are going all in the wrong direction, and including aquifer recharge. So I'm just concerned with some of these issues. Now, it's true that you could make some projections and say, well, if everybody agrees to reduce GDP growth, that would be beneficial for climate. But that's not going to happen. As we saw, even in countries like the European countries, the average GDP growth rates are really quite low now, but still people are not willing to pay high levels of taxes. So I think we've come to a situation where we are heading for an environmental disaster. And so it's true that we want to use as much renewable energy as possible. And that's one of the points I'm trying to make here, that we have all this antiquated equipment in countries like India. And it's true, it requires subsidies to be replaced. But the fact is, the whole global situation is in dire it's quite dire, and therefore we have to have evidence-based policies, and we can say, yes, consumption, especially in the US, should fall, but no politician can remain in power making that claim, and so we're back to this kind of business as usual.
Thank you, sir.
Well, thank you very much, Dr. Bhargava. It's a remarkable summation of a very large number of factors which impinge on climate change. You have really pointed out, your summing up is beautiful. But what I find in practice in government offices, they're all fragmented. How do you bring this knowledge together in policy formulation in an integrated way is a great challenge. That's a great challenge, not only national, but global level, regional level, and so on. But I entirely agree with you that the whole area of demographic change, and we are having the International Water Day in a few days, and the importance of the water, and how we are going to integrate all this in our climate risk management strategy is a great challenge. And I think talks like what you have given now are very important to at least awaken the fact that there are many factors involved, not just one. You even refer to biofortified crops, those which are rich in iron, iodine, because not normally people look at that depth of these issues. Thank you very much, and I hope we will have more of these talks before policymakers also, not only scientists who are already convinced, but those who are to make public policies. Thank you very much for coming. We're very grateful to you. Very grateful to you.
Thank you very much.
Thank you, Professor. I thank your colleagues, scientists, researchers, students, and ma'am, you want to ask a question? Okay. Thank you very much for coming here, and thank you, Professor Lokbar.